Uh, my first talk today is optimizing MySQL without SQL or touching my.cnf. And there is a reason why I called this talk like that, because there is a bit of information about me. I'm SWE for last 10 years, and I joined Dropbox as SRE in 2015. But despite I'm working as a member of storage team and I'm working on metadata storage and touching MySQL a lot, I had no DBA experience previously. So I have no idea about how to optimize or speed up MySQL, modifying MySQL configuration. And let's look what is a Dropbox today. So Dropbox today is 500 million users. We have 200,000 business users, and users are uploading 1.2 billion files every day. It's a quite big scale. We have tens of thousands of servers. We're located in multiple data centers across multiple continents and multiple countries. And we're storing petabytes of metadata and exabytes of raw data. And that leads to quite obvious problem that we need to optimize our performance, because we want to save on the power, we want to save on the number of hardware we are buying, and we want to reduce latencies, etc. So this talk is covering optimizing MySQL, and mostly I'm covering how we are building MySQL, and just rebuilding, like, is it make sense to build MySQL in your own infrastructure, or is it just enough to use vendor packages? And for every performance improvements, or like for every performance change, it's actually reasonable to use benchmarks. And for benchmarks, we're using sysbench. And this is an example of a configuration we're using for running sysbench. So we're running several tests with different number of threads, and number of threads is variable. In this particular test, we're using a number of threads from 1 to 64. Each test was running for 5 minutes. For testing compute, it's enough to run on 5 minutes. We're just using standard Lua LTP read-write test from sysbench, and for this particular test, we're using master branch, and this is quite fresh checkout of sysbench. As far as I understand, there would be a sysbench talk later this day. So just we're creating 16 tables. Each table contains 1 million rows. These are testing subjects. This is examples of hardware, not exactly hardware, but systems we're testing on. We're historically worked for quite a long time on Ubuntu 12.04, and we're still in the process of migrating to Ubuntu 16.04. And both systems have different kernels. We're currently running 3.16 on 12.04 and 4.8 on 16.04. There's a different set of compilers available on each platform. On 12.04, these are GCC 4.6, 4.9, and Clang 3.0, which are pretty old by this time. And on 16.04, these are GCC 4.9, which is just backported for backwards compatibility to 16.04, GCC 5.4, and Clang 3.8. So both machines are running this specific CPU, and both machines are completely the same in terms of hardware. So speaking a little bit about build infrastructure at Dropbox, we use Bazel as our build system, and Bazel is tightly integrated into our build system, but MySQL uses CMake as a build system, And Bazel is not compatible to open source software. And if you're trying to build something with Bazel and integrate something into your Bazel build, is it AutoTools based or CMake based or any other build system, you're literally screwed, and you need to do the same, or maybe we will go into open source that. We actually wrote a CMake to Bazel converter tool, which actually helps us to integrate into Bazel build. It's actually not that hard to write that. I actually did that during one night. Important stuff before running any benchmarks, and actually made this mistake on one of these machines, and thanks to Ubuntu developers, starting from Ubuntu 16.04, CPU FREC scaling governor set to power save, and your CPU is just in power save mode. So don't forget to set CPU FREC performance governor. And let's start. So what we're going to optimize is optimize MySQL, just rebuilding it. And one of advanced compiler techniques is profile-guided optimizations. And what is a profile-guided optimizations? You're literally building special build of your binary, which starts collecting training data. And then, when you have enough training data, you're rebuilding your binary again, and it optimizes branches, it uses better branch prediction, it relocates code paths, it has better inlining because it actually knows statistics on how the code is used. So it usually requires to rebuild, but not in the same, not in every case. In case of Clang, and as far as I understand, thanks to Google, Clang can use perf data. So you don't need to rebuild. You can just collect perf data and build using perf data, which is a bit easier. So a common mistake, collecting profile data from unit tests. Don't do that, because unit tests usually are checking corner cases, and you don't want to optimize for corner cases. So literally your code would be fast on some corner cases like return exception, but not in any other case. And let's see how we're building with GCC. So to build profile-guided optimization build with GCC, we have two flags. One of them is to enable profile data collection. It's fprofile generate. There's another variant of this flag which allows you to set the output dir where you want to write profile data. And second flag is fprofile use. It actually, when you're rebuilding your binary, it uses profile data. And in case of MySQL, it doesn't work. And it doesn't work because MySQL is multi-threaded application, and profile data would have incorrect counters. And in order to fix that, we need to use fprofile correction, which would tell GCC just try to fix counters for us. And bad news for Ubuntu 12.04 users. It doesn't work with GCC 4.6 and 4.9. And flags are working, but PGO doesn't work for MySQL. And yeah, that's about GCC. So another compiler we have in distribution is Clang. And Clang is set up a bit differently. It has a little bit different set of flags. And it's fprofile generate, but before they introduced command line arc back compatibility of GCC, it was called a bit different. It was called fprofile instart generate. And there is an interesting flag which is fprofile sample use, which is exactly the flag I mentioned to use perf data. So bad news again for Ubuntu 12.04 users. No PGO support in Clang 3.0 at all. Like, at all. So we rebuilt MySQL with PGO, and we ran tests with Sysbench, and we did several passes, so we don't have any fluctuations in our tests. And here, results for 1204. I don't know how the colors are looking here, but I can tell what's there. So we have Clang 3.0 is a winner. It produces binary with highest throughput, and throughput is something about 10% more on using building of Clang than building of GCC. But in the same time, both GCC and Clang here are pretty old. But if you're stuck with 1204, and you shouldn't do that, because 1204 LTS ends this April, it could be a good choice to just rebuild with Clang 3.0 and get like 10% performance improvement. And here, how response time looks, and it is the same. So the lower is better, and Clang produces lower latency binaries as well, which is good. So that slide is more interesting. Here we have Sysbench results for 1604 builds, and on 1604 we're actually able to use PGO, and there's a bit interesting, and we haven't found out why, but GCC 5.4 produces really bad results. Maybe something's broken with our compiler, and not the problem of GCC, but of our build infrastructure. But we decided just to include that, to be honest. And GCC 5.4 with PGO produces pretty good results. It's generally 20% faster than just GCC 5.4, and you can achieve that just rebuilding your MySQL binary using PGO. And every other compiler is a little bit slower, but just using PGO, you can achieve 20% performance improvement. And here are latencies. So looking at it, the lowest part is GCC 5.4 PGO build. For that test, we did not try Clang PGO builds, so we don't have Clang data here yet. But it would be interesting to compare Clang PGO build versus GCC PGO build. But latencies are also something like 20% lower for PGO builds. So this is one of interesting optimization techniques when you're not touching MySQL configuration at all, and you're speeding up your MySQL. Another interesting advanced compiler optimization technique is link time optimizations, also known as full program optimization. And it is supported by both modern GCC and Clang, but MySQL code base is not LTO compatible at all. And a little bit, what is LTO? LTO is when compiler, instead of producing object code in compilation units, it produces intermediate representation, and linker does actual compilation and optimizations. So you're postponing actual optimization to the link stage, and linker sees all object files and knows how to inline. Like it can inline code from other object files, which is not available without LTO. And but actually, it's easy to fix in code base, and we're going to start working on that pretty soon. So we're going to send patches for that. And it would be interesting to see LTO results on other projects we're using. We saw something about like 5% performance improvement, so which is also interesting. And so that's basically it. What we accomplished by this time with optimizations. We have like 20% performance improvement just rebuilding MySQL. And we have actually more ideas what we want to do next. We're working on, because we're using Sysbench as a training data for PGO, and we're testing with Sysbench again. We actually plan to start using real-world training data. And for that, we're going to we actually started contributing to Percona playback, and we're going to just play back the real production traffic we have in order to optimize our builds for production. And another interesting thing that it leads to interesting question that we don't have only one single database. We have many databases, and workload profiles are different. And we haven't decided what to do here because it would be interesting to have some generic training data we can use on every production database. So another interesting option is building with M-Arc native. I have mistyped there. So it allows compiler to use latest extensions like AVX or AVX2, and usually it just uses some generic compiler set, CPU instruction set. But with that, you can also achieve like 3-4% of performance boost. And another interesting thing that when we're running MySQL in production, we're usually running one single instance, multi-threaded instance on single machine. But we actually see in perf data to see QPI interface, and usually when you have multi-core machines, you have usually you have 2 slots, and CPUs. If one CPU want to access the memory from another CPU slot, it uses QPI link, and it's actually slower than using local memory. Not significantly slower, but still we see like 3-4% here. And another option, we probably would run 2 MySQL instances, 2 shards on single hardware machine, and each bound with NumCTL to each slot and to each memory slot. So that's it. Questions? Yes. So could you repeat the question? Yeah. Could you repeat the question? Do we have some public Debian package with? Yeah, like as I said, we are not using Debian packages for our built infrastructure. We're using with Bazel, so unfortunately we're not building that packages. So yeah, so the question is how PGO works. So PGO build collects data on branch users, and it writes that into GCDA files in case of GCC, and using that statistics, it just writes statistics. It can understand which branches occur earlier, which are not. Yes, it's exactly about writing object code.
Do you
So we are collecting basic events. I can, yeah, I don't recall correctly what is the size of per data we have. But we're also running a top on the machines. So, yeah, okay.
Thank you very much.
Thank you.
Will you be around? So Maxim will be around, and so if you have questions, just take him, go outside and ask him so many questions, pay him a beer, and it will speak for a full day, right?